Pause the recording so we can capture this for all posterity, and we'll get underway. So thanks folks for joining. My name is Nick Ray. I'm with RunSafe Security, joined by a couple other folks here for our webinar from Oracle, as well as a close collaborator of ours that we were introduced to, SANS. And the topic for today is securing open source infrastructure in the cloud, and specifically with Oracle Cloud Infrastructure. So we're real excited at RunSafe to be partnering with Oracle and deploying some of our solutions on their marketplace. And we'll walk through today some unique perspectives and technical capabilities around securing open source, leveraging RunSafe Security's technology, as well as the context around deploying that technology within Oracle Cloud Infrastructure. So I'm going to be your MC for today, and I'm going to introduce a couple of other speakers that are joining. So as I mentioned, my name is Nick Ray, and I lead the market development team at RunSafe. Been joined by Phil Griston, who we've worked really closely with at Oracle, leads a business development lead, looking after security and networking partnerships there. And it's been a real joy working with Phil as we've deployed various solutions on Marketplace. And I'll be handing it over to him in just a moment. And we're also joined by Chris Crowley, who's a close collaborator with RunSafe and has done some research and evaluation of RunSafe technology, is a brilliant cybersecurity consultant, and we were introduced through our work with SANS. He's also a fantastic cybersecurity instructor for SANS, and his section will be highly technical. So for the folks that love getting into the bits and bytes, that section is for you. So I'll run through our agenda really quickly here, give you a sense of what's about to unfold over the next 45 minutes or so. We're going to start out with an OCI perspective around the shared security model in cloud. We know that there is a portion of security that falls on the shoulders of the cloud provider, but also the end user. So we'll hear Phil talk a little bit about that, and also some broader elements around Oracle Cloud Infrastructure as a broad offering in the cloud space. And then I'll jump back in and walk through RunSafe's unique perspective on open source vulnerabilities, some research that we've done externally, and then walk through a bit of a new approach on how to reduce your attack surface when deploying open source in the cloud. And then I'll hand it over to Chris, who's going to walk through a live open source exploit, pseudo live, if you will, but it's a really cool deep dive into an open source exploit that was found in Apache PHP, and then look at how RunSafe impacted that particular exploit. And then we'll wrap up with some creative options that RunSafe and Oracle have put forth on Oracle Cloud Marketplace, as well as some other solutions that plug into OCI infrastructure in general. So with that, Phil, over to you.
Great, thanks Nick, and hello everybody. I'm excited to be here today. It's always fun working with the RunSafe guys. So for those of you that haven't kept up with what Oracle's doing in the cloud space, or maybe not at least beyond hearing about the TikTok saga, I'm going to give you 2 minutes on why you should take a look at what OCI is doing here. And then I'm going to give you like 3 more minutes on our take on cloud security and why we're excited to work with companies like RunSafe and you as we all work to secure your data in the cloud. So I expect that you already know that Oracle is one of the largest software companies in the world and one of the 5 largest SaaS vendors in the world. So when we set out to build Oracle Cloud Infrastructure, which is the platform that we run our SaaS applications on and that we offer as infrastructure as a service or public cloud, you could say that we were late to market. And frankly, that's given us a huge advantage because we got to see the mistakes that others made before we completed our offering. And we had the opportunity to maximize that by hiring some of the key architects from the first generation cloud platforms and giving them the time and resources to build a second generation platform. So if you can, next slide, please, Nick. Thanks. Of course, some things never change, and we are a public company, so I've got to notify you that the plans that we discuss here should be confirmed for your specific situation before they're being relied on for purchasing decisions. But with that out of the way, let's talk a little bit about how we set out to build OCI and what the three guiding principles that we kept in mind as we did that. Firstly, we wanted to deliver the best price performance for any public cloud offering. We saw an opportunity to build an architecture that gets the best from the components used as well as using the best components. So as an expert in high performance hardware, we own Sun Microsystems, as you probably know, we had the advantage of controlling a lot of our own supply chain and being the only public cloud provider with access to platforms like Exadata, where most of the world's largest and fastest databases are run. But that hasn't stopped us building partnerships with companies like Intel, AMD, NVIDIA, to bring their latest and greatest platforms to OCI. And if you look at the independent performance stats for public cloud offerings, OCI is at the top of all of them. So delivering high performance was incredibly important for us, but doing that at a low cost is what has brought us customers like Zoom and 8x8, moving their applications to be hosted on OCI. And it's why we're winning so many high performance compute projects from companies like Nissan and other car manufacturers that do a lot of modeling, because we can give them that price performance. They can finally get the performance that they need to move from on-prem solutions at a compelling price point in a truly elastic environment that allows them to scale up as they need it, as they work their projects. The second pillar of our design philosophy was that the platform and the business processes around the platform need to be built for enterprises. Of course, our initial focus was the Oracle customer base. There's hundreds of thousands of database users and tens of thousands of Oracle application users out there. And we needed to allow those large enterprises to take advantage of cloud economics without having to go through long re-architecting projects. Not every application needs to be re-architected as you move to the cloud. We wanted to make it easy and allow the customers to have a choice as whether they wanted to do that at this time or not. So we designed things to make it quick and easy to migrate into the cloud. We've kept the pricing simple. Most of our prices are the same worldwide. And we offer the same services in all the regions that we have from day one, so that global companies don't have to worry about differences in the places that they do business. And final pillar, which we'll talk more about in a few minutes, is that security had to be the foundation of everything we built. This is enterprise-grade infrastructure, so security can't be a bolt-on afterthought. And this approach has enabled us to scale extremely quickly. So last week in Dubai, we launched our 25th geographic region. We'll have 11 more public regions this year. We've got multiple levels of government regions in the US and Europe, with more to come. And several of our regions are interconnected with high speed, low latency, and integrated identity management with Microsoft Azure data centers, so that customers can split workloads seamlessly between Azure and OCI. We know enterprises are and will continue to be multi-cloud, so we've designed for that. If that isn't enough, if you have data sovereignty or security issues that mean you can't use public cloud, we'll bring the whole thing to you with a dedicated, what we call a dedicated region cloud at customer, which means effectively we build our public cloud platform in your data center behind your firewalls so that you can control it, but we manage it for you. So this gives you access to virtually all of the services that we have in our public cloud offering in your data center with the same pricing as our public cloud offerings. Next slide, please, Nick. Thanks. But today's about security, so we'll get a little more into that. As I said, any design change or new service at OCI has to pass a range of security audits throughout the design, the development, and the implementation phases. We don't set out to make a profit from security. Many of our services, such as DDoS avoidance, WAF, and our security posture management offering, CloudGuard, are free to your users. We set out to integrate all those security offerings, both our own and third parties from guys like RunSafe, in a way that makes it extremely easy to use them and use them reliably. Oracle's worked with our customers to protect the data in your databases for decades. And we use that knowledge that we've gained over time to protect your data as we move it to the cloud. But most of all, perhaps, we know that security is a team game. We have to work with you and we have to work with third parties to make sure that we secure the entire environment. So let's dig into that a little bit more. Next slide, please, Nick. Thanks. You've all seen the shared security model for cloud services. And obviously, we set out to ensure that platforms are as secure as they can be, but you still have a major role to play. We want to help you succeed, both by offering our own technology for you to use and by working with a large ecosystem of security vendors to provide secure options for what you need to deploy. And we know that that deployment is going to be a mix of third-party commercial products and open source software. Next slide, please, Nick. So why is this really important? Well, late last year, Gartner published their thoughts on where the weak links of a shared responsibility model lay. As you can see, Gartner thinks that it's going to be the customer's fault. But frankly, that raises concerns about our business model. We can't be successful if your business is not successful. And that means if you're not secure, you're not going to be happy with us. So laying blame on our customers for security issues is not a winning strategy. We have to do everything we can to help you secure your environments. And that's why we're excited about the opportunity to work with and learn with experts like RunSafe and the SANS Institute. Memory exploits are a large and growing concern for enterprises, and we believe that RunSafe has developed some excellent technology to help protect you from these threats. And that's why we're happy to make these solutions available on OCI and through the marketplace, and to join panels like today in hopefully educating you a little on how to protect your company against these exploits, especially in open source, which has many advantages, as we'll discuss, but also some inherent risks. So with that, and understanding why Oracle's here, I'd like to thank you very much for your time, and I'm pleased to pass you back to Nick for our next section of this morning's content. Thanks.
Well, thanks very much, Phil. Appreciate the run through. That was fantastic. I think that sets the stage perfectly for where RunSafe plugged in to the shared security model. And full disclosure, we do actually intend to make a profit on security. So I just want to make that totally clear. Love the altruistic approach from Oracle on that. But yeah, if we didn't make a profit, I wouldn't be sitting here. So just being honest about that one. But we're happy to do that with Oracle and really excited to present to you today. So I'm going to walk through at a high level our technology, our background a little bit, and then as I mentioned before, I'll hand over to Chris. So what's RunSafe's mission? We seek to disrupt hacker economics by immunizing software from attack, a completely new method that is starting to get a lot of visibility in the general cybersecurity industry, but it's a newer approach. And it was born out of our founders' experience for many, many, many years on the offensive side of cybersecurity, working on behalf of our great nation here. So as they were undergoing their missions on behalf of the US, they came back over and over and over again to a particular attack method that was very, very effective. And that was leveraging memory-based vulnerabilities. And so they developed a very strong expertise on the offensive side, which then uniquely positioned them to be experts at building a solution against that. And that's where we disrupt the hacker economics. An attacker, as we all know, only needs one way in, and you've got to plug as many holes as possible. So we kind of shift that equation around and put the economics back in your favor, the defender's favor, by immunizing software. Now, I mentioned in the beginning that we've done some cool research with a third party. In this case, it was with the North Carolina State University. So I'm going to walk through some of that as we did really extensive research on this whole category of memory-based attacks. It's ultimately the go-to attack method, which we already knew, and then this was obviously validated. So this is some of the data that came out of that. And as you might imagine, the most frequent CVE vulnerability category, memory related. About 40% of all CVEs in the software that was analyzed, which is a whole host of open source based packages, memory came up more often than anything else. And what's even more dangerous is that about 60% of the time, there were actually exploit scripts available for these vulnerabilities. So not only did the vulnerability exist, but could actually be weaponized and used to affect real harm on individuals running this open source or businesses. Now, additionally, we found that the severity of these particular vulnerabilities was also very high as a class, 7.2 to 9.8 on the CVSS scale, compared to other attacks, which were in the 4.9 to 6.7. So much more effective at wreaking havoc in a customer's environment. And so the approach typically has been to patch these vulnerabilities and leverage scanning tools to scan code for vulnerabilities, in the development process or in the deployment process. And what came out of this research, which was really interesting as well, is that if we look at Linux, broad Linux, which is a huge swath of open source code, obviously, and the CVEs that came out just sort of organically, publicly across the cybersecurity landscape, you look at those CVEs compared to what very common scanning tools found, 2.5% of the time is the only amount that these vulnerabilities were actually detected. So the scanning tools that we all use that we think are effective just aren't finding these particular types of vulnerabilities. And when they do actually find them, it takes forever to get them patched. The median fix time was 567 days. So ultimately, patching and scanning just doesn't solve this particular problem. Not that you shouldn't do it, but it's just not effective as we might think. It's some interesting examples that came up recently out in the wild. This was about 6 weeks ago. Microsoft, there was a DNS vulnerability found in Microsoft Windows that was 17 years old, believe it or not. So these vulnerabilities can linger for an incredibly long period of time. And then annually, MITRE produces their CWE rankings, and in 2019, a memory-based attack was rated as #1. And 5 of the top 10, or 6, I believe, were in the memory category overall. And then last year at a security conference that was hosted by Microsoft, by their own admission, since 2012, 70% of the vulnerabilities in Windows were memory-based. So these are all things we knew, but did extensive research with external parties to really drill down and obviously validate the significance of this particular problem. So how do we fill the gap, right? We know that patching and scanning isn't quite getting it done. All of the traditional defense in depth tools that are out there will at some point along the way be breached. And not that you shouldn't do all these things, you absolutely should, but at the point of attack in the code itself, what can you do? And that's where RunSafe technology comes into play. By immunizing code at the point of attack, you're effectively closing that gap. So it's a new approach, right? The category you might have heard, it's RASP, R-A-S-P, Runtime Application Self-Protection, MTD, or Moving Target Defense, or some acronyms that are becoming more and more recognized, and that's the area in which we play. And the solution that we brought to market is called Alchemist, and there's 3 general areas of capabilities. So Alchemist Source, which seeks to immunize source code or human readable source code. Alchemist Binary, which seeks to immunize code that's already been compiled or in binary format. And then Alchemist Repo is just a repository of open source tools, common infrastructure that has been hardened by Alchemist Source. And we'll come back to those a little bit later, but I want to give you a sense now of how the technology actually works. This is where the fun part begins for the folks that are the propeller heads out there. So RunSafe Alkemist is very, very straightforward. It's a transformation engine, and we take in unprotected software that's obviously vulnerable to attacks, and we apply protections to it when that source code or binary code is ingested into the transformation engine. and out the other end, it's packaged back up and as intrinsic or passive protections built into the code that allows the code to protect itself. No agents, no monitoring, just code that is capable of blocking a whole class of attacks. And it's seamlessly integrated into the development lifecycle. And we'll take a high-level look at how that's actually done. So the implementation points are pretty straightforward. You'll see here from left to right a very typical common software development lifecycle, aka DevOps architecture, DevSecOps architecture, and we plug into very obvious stages here. So as source code is getting pulled from a repo and then getting compiled, our source-based protections will integrate into the compilation process. It's a very straightforward process, usually a few lines of code change in your make file or your build script, and you're off to the races. Similarly, on the binary side, as binaries are dropped into your repository or deployed from your repository, Alchemist protections can be layered into those binaries as well, again, with some very simple and basic modifications to your deployment scripts. So now how do the protections actually work? What are we doing? What is Alchemist doing to the code that allows it to eliminate an entire class of attacks? So I'll peel the onion back a little bit on the source side and the binary side. So on the source side, human readable source code, Alchemist leverages a technology we call load time function randomization. And on the binary side, we leverage a technology we call basic block randomization. But the lowest common denominator here is leveraging randomization to thwart an attack. And so on the left, you see, this is just a very simple example of a program that's unprotected. And these functions in a program will call each other in order, 1 to 3 to 2 to 4 to 5. And there might be a vulnerability an attacker may have discovered, and it's in this specific memory address location here at the bottom in function 5. But once we've protected that piece of software and it's been hardened, what happens is function 5 moves and is shuffled into a different memory address location. So the attacker thinks it's in this bottom memory address location, and they launch their attack and nothing happens. The attack is effectively immunized, or that the code is immunized from that attack. So that's at a high level how it works. And if we're looking at source code, it's the randomization of functions. And if we're looking at binary, it's the randomization of basic blocks inside that function. Simple as that. So now that you've got a grounding in how the technologies actually work, I'm going to hand it over to Chris to walk through the exploit deep dive and show you how this actually behaves in a real world scenario. So Chris, feel free to take over the screen share and have at it.
Okay, there we go. You should be seeing my screen now, and I'll go ahead and start my slide deck. So just to introduce myself, my name is Christopher Crowley. I've been working in computers for a really long time. My first job was in the 80s when I was 15 years old, running tape backup for Ultrix and VMS systems. Since that time, which it's been a while, I've been working in a number of different sectors, usually on the operations side, and cybersecurity was something that I really started delving into out of necessity, just because systems that we were managing were getting attacked, and I had to deal with a bunch of incidents and legal issues and other things along that line. And so this is something that I've been working in for quite a period of time now. I teach for the SANS Institute. I work as a consultant. I've been looking at a number of different areas in information systems and security. I consider myself very much of a generalist. I have skill sets on the exploit side. I have skill sets on the pen testing side, and some focus in mobile. I've always been a defender of systems, but as a result of sort of my interest, I've oftentimes dabble in the exploitation of systems or attack of systems in order to demonstrate weakness in order to more effectively defend things. So just a little bit about me and where I'm coming from. And today, what I'm going to talk about, first off, I'm going to share a couple of thoughts that I have on open source. And these are my opinions, and I have one reference to point to for sort of a basis of that. Another thing that the reason why I'm here and the reason why RunSafe invited me to talk was because I was contracted to do some work via the SANS Institute Analyst program to do a technical assessment of their product. And so I'm going to talk about the work that I did. I really like doing things in a methodical way and sharing sort of methodology and details and sort of exposing things. So I'm going to tell you what I did, try to keep it as brief and as simple as possible, but it'll get fairly deep and technical in order to make sense. If I'm trying to explain how protection works, I need to first see how the exploit works and then see where the protection actually intervened, from a reversing type perspective. So that is what I'm going to talk about today. So starting off, my opinion about open source and risks in open source. One thing that is an advantage of open source programs that's a differentiator from commercial programs is you usually can, if you have the skill set and inclination, compile from source in order to change the compilation options to achieve greater security. And so one of the things that Nick was just talking about is them having some bolt-on after the fact of things being compiled, which is a potential advantage, bringing a commercial solution to sort of give that same sort of security control that open source would otherwise have. And then I hear arguments on both sides of this. And so I'll just list it as questionable that open source software is more or less secure because of the availability of the code. Now, some people will say, well, then attackers can look at it and they'll be able to find flaws, which is true. But then the other side of that is the defenders can also look at it and they can find flaws and point things out from a security research perspective, which gains sort of a greater degree of visibility. And if you have 5 experts looking at something great, even better if you have 500 experts able to look at that. So an interesting resource that I would compel you to look at, I think that it's a reasonably objective stance where Mudge, who Loft Heavy Industry Mudge, not Raphael Mudge, but he has cyberitl.org, and this graphic is from there where they actually have a ranking of comparison of operating systems. They also have a bunch of other programs as well, but it's essentially comparing an open source to a commercial product. And what's interesting in this is they talk about the different facets of open source versus commercial. And so effectively his system of ranking the methodology is exposed, and it does not have a conclusive sort of answer of like, yes, commercial is better or open source. It's more of a, here's where this is better, here's where this is better based on our assessments and the different facets of protection. Another thing that I hear in terms of open source as a concept is insiders can actually introduce flaws more effectively in the open source space. I hear the counter argument as well for commercial. And so I don't think that, that's a definitive thing one way or the other. Both software development programs have threats of insiders. Another thing that people say is commercial source will give you better support. Not necessarily the case. I don't see that each sort of scenario makes it so that we're getting better support. Oftentimes, because we're paying a company, we think that we'll get better support. The fact is we don't always get that. Hopefully you do, right? That's why you would be paying them, right? But I don't see a clear-cut benefit there. The only real clear-cut benefit that I can point to in open source is the opportunity that you have to review the code, or depend on other people to review the code in order to assess the security posture, and then potentially being able to actually recompile in order to enhance defenses. And everything is vulnerable in some way. Most of the software that's out there is vulnerable in ways that we don't yet understand. That's why we get patches, because they're vulnerable already and we just discovered it and now we have to retroactively fix it. And I will say that attackers are definitely attacking software. And attackers who are good will certainly take advantage of the visibility of open source software. They, unlike most of the good people out there, are simply not sharing their findings. They're leveraging them to accomplish whatever their malicious objectives are. Okay, so that's sort of my background thought on open source as a concept, since we're touching on that. And I think that there's almost equity in terms of that. And there are a couple of things that, if you take advantage of it in the open source space, you can gain some additional security enhancement by doing those things in terms of recompilation and review. So methodology for the analyst program assessment was pretty simple. I got a license. I was, basically recompiled a bunch of stuff. I was sort of asked to focus on highly deployed or broadly deployed software, identify an exploit that was relevant to that, dig down into that exploit, look then at how the RunSafe product actually protected. So the methodology that I used in almost all cases was leveraging source. Since I was using the open source sort of software as a space, it also let me focus on specific versions, because I didn't want to have to go back to RunSafe and my research work and say, oh, I need a version of PHP compiled with this, with these compile times options, with this, because this specific exploit targets that thing. I wanted to have independence to be able to do that assessment. So that was the work that I did. And in this work, there were a couple of things, and there's a paper that's forthcoming, and there's a webcast that I already did on this in even more detail. But in this, I came up with the Carpe Diem as an exploit that I use in order to target Apache. The Carpe part of this is the CVE Apache root privilege escalation. This is actually a root privilege escalation through Apache, and I'll talk about how that works in a moment, which is something that isn't usually associated with Apache as an attack. There was also, as part of this attack, a PHP Use After free that was leveraged in order to deliver the code in order to be able to do this actual attack. And so Apache has a strategy that the child worker processes are unprivileged, which is a really good architectural thing in order to do that. But the idea is that the Apache parent process, which is not handling web requests, actually runs as root. And so this attack leverages the fact that most Apache instances which are installed to do a daily graceful restart. And DM, day in Latin, carpe diem, seize the day. The idea of this attack is that it would poison the shared memory space, wait for the graceful restart in order to take advantage of it. And when that graceful restart happens, the graceful restart will actually basically execute the poisoned contents of memory, ending up with being able to then run a command as an attacker with root privilege. Okay, so the out-of-bound memory flaw is what is actually attributed as CVE 2019-0211. And in terms of this being a broadly distributed piece of software, roughly Apache is, a third of commercial websites. In this case, commercial websites of internet sites. It's roughly a third for Apache. Apache plus PHP on a lesser, subset of that, but still about a third of the websites in the world have the Apache. And at the time, the flaw was something that was very broadly distributed. So when this was released, Charles Full was the security researcher who actually released this exploit. When this was released, the PHP portion of it was actually a 0-day. He said that he contacted PHP. They didn't address the security flaw. And so in order to release on his timeline, that portion of it was actually 0-day exploit available, no security patch available for the PHP portion of this. And so this particular attack, in order to get it there, two main ways that I think that this would have been executed. One was attacker gets some sort of a web shell or SQL injection or some other base level access through one flaw, and then leveraged this to get root level access on the host. The second way, which is interesting for large managed security service provider type organizations who are allowing customers to put PHP code onto their web servers. If you have a customer who's allowed to load their own PHP code, they already have the access necessary, and they don't need to chain a previous exploit in order to get this there. Okay, and so this is sort of the sequence that I see what's going on. So let me talk about the actual attacks. The first part of this is the PHP Use After Free flaw. Now, use after free, the general notion is that some portion of the code has allocated memory. The code then releases that memory, but another portion of the code is later going to go back to that memory location and read from that memory location. Now, the program thinks that that memory location is available. The attacker does what's called a heap spray to be able to put lookalike portions into the memory so that hopefully when that freed memory is read later, because it was used after it was freed, then that lookalike value that's present tricks the program into running the code that's in place. Okay, and so the payload that is built by the PHP Use After Free is what is ultimately going to be exploited by Apache when that out-of-bound read is triggered in the code. Okay, and so this particular page that executes this builds up the payload from a couple of things, and it uses what it calls the bucket, which is where the stuff that the attacker wants to run is written. And then the payload is a combination of the bucket, a method that's in place, and this properties array. Now, the method is going to be executable code, which is ultimately pointed to by the child init method inside of Apache when it goes to restart a child process. And this PHP exploit, or the PHP portion of the full exploit, is going to put some stuff into memory so that if any of the areas get read when they are used after freed, then all of the stuff that's necessary in order to execute the child init function is in place already in memory. And this is some poisoned areas of memory. And so we have the bucket address, the method that's necessary in order to execute, and then the details of an array of data which would be necessary for that function when it's called. Okay. So PHP Use After Free flaw is going to look for the appropriate area of memory to do this heap spray. It's going to also identify all of the different child processes for the Apache instance. Now, you probably realize this, but this PHP code is running inside of an Apache child worker process. And that child worker process has access to a shared memory structure, which is shared between the parent process of Apache and all of the other child worker processes, which is actually where the out of bounds flaw takes place. And so the PHP code uses the access to shared memory in order to read where all of the child processes are. Then what happens is the graceful restart is going to destroy all the child processes, and then it's going to initialize new child processes in order to start handling web requests. Now, in Apache restart, you use the APACHECTL, Apache control program, in order to restart. And there are two forms of restart. Restart, hard restart, which kills the parent process and starts a new parent process, or graceful. What graceful does is it actually keeps the parent process alive, exits all of the child worker processes, and then spawns up new child worker processes. So in the effort of me doing this assessment, I was using GDB in order to see the different code that was running. Basically, the prefork.c code doesn't adequately protect the shared memory location. And the child init method, when it is called, is under control of the attacker. And so the attacker uses the access that each of the child processes have to this area of shared memory to look at a structure called the bucket, which is its own little shared memory area. But inside of the bucket, for each memory area for each process, is an all buckets structure that points back to basically the structure that the Apache parent uses in order to look where all of the different child processes are, and the attacker gets control of that. And so I think that this particular comment helps us to understand how this works. Here we see from inside of the Apache code, this needs to be done before we switch UIDs so we have permissions. And it then does this thing where it reopens the scoreboard and it takes the child init method from shared memory and executes that. And the attacker, via that PHP Use After free, has poisoned that child init, which then points it back to a destructor method and has already put the appropriate structures in memory so that it looks like it's being called with something that's legitimate, okay? And so there are a couple of other things that are necessary for this to work, all of which are satisfied in the particular exploit. And so the child init method has been pointed to the Zen's object destructor method, which is called in the P object, which is the specific one, which is the use after free that has been created. That ultimately points back to a system call. Now, instead of running child init, the Apache, during its restart, is going to point to the system call that the attacker has poisoned in memory. Okay, so all of that work is done to ultimately call this system. And when that system actually happens, that system is called as root. Okay, so I'm going to just show you what this looks like in terms of the code when it runs. I'm going to run this video. This is me actually running this on my test system. Here we have the system in memory. This is me running GDB against a running Apache parent process. And I have a couple of things that I'm going to do to check. Ultimately, the exploit that I'm going to run is going to try to copy Etsy's shadow to a file called root seized it in order to demonstrate that I run this with root level privilege. And down here in the corner, I have a check to see if seized it exists, and the loop will run until seized it no longer exists. So after I start that loop up, I'm going to go and run the PHP exploit, which I just call a web page, and grab that. Now this is successful, but this is just the PHP portion of it. And it's not until the Apache graceful restart happens that the root seized it file will exist. So I start my Apache, I gracefully restart my Apache, and you see in the bottom right-hand corner there that the file will exist as soon as I do that. Good. I have a little check in here, and there down in the corner we see that that was actually seized. I seized the day. I seized the Etsy shadow file as well. Right now, the next thing that I did was I actually used the RunSafe tool. I had to protect a number of areas in order to make this work. And when I ran this with the RunSafe protection in place, the exploit actually failed. So here's the video that I have for that one. So here, no thanks. So here, and this is actually kind of important, and I'm highlighting this, and I'm just going to pause the video. This actually is a disassembly of Apache parent process while it's running, but here the system is actually unmangled, and this is because the libc is protected by RunSafe Alkemist. And so this RunSafe Alkemist protection of the system call that's in place is actually ultimately what stops this exploit from running. Okay, so here you're going to watch me try to do the exact same thing. I start up my little check, make sure that this is looking for the seized it. I launch my PHP exploit in order to actually poison memory. And when I do that, the PHP portion of the exploit still succeeds. Sorry, fumbling between different windows. So this PHP is the exploit. This part works, right? This gets the Carpe Diem PHP page. This actually says copy Etsy shadow to root seized it. That works. And then when the graceful runs, it never works. And so I can run this over and over and over and over again. It doesn't work. Why? Because the liblfr, the RunSafe product protections in place are actually preventing the exploit from getting to the system call, as Nick was describing earlier, effectively stopping the attack. So this is what it looks like in the GDB of the unprotected, and part of this that makes it really obvious is the mangling that's in place for the system compiled, for the previously compiled libc, which is protecting the system method. And so this is the protected version where we have the system method. You notice the name mangling is different. This is the RunSafe instance of it. The assembly code also slightly different, because what they're doing effectively is moving this around in memory. So the attacker structures are not going to be effective if the RunSafe protections are actually in place. So there might be additional opportunities to pursue and do additional development or additional exploit, but the clear indication is when protecting that libc, the associated library from Apache, and the attacker's otherwise effective exploit is actually thwarted by liblfr when the compilation occurs against the system's libc, where the system method is actually in place. And it would take a lot of additional work and manipulation to try to do something else in order to get to that particular exploit. So the kind of takeaways from the assessment, and again, I have a lot of additional write-up and material around this, but the takeaways are, yes, it worked. Yes, it stopped the exploit, and the protections in place actually against something that, if this was in place when that came out, it would have stopped the exploit as released in 0-day form. So thank you very much for that. Hopefully that was informative.
That was great, Chris. Thanks very much. Appreciate it. Definitely every time I see it, I learn a little bit more, and hopefully the folks out in the audience of a technical mindset also were able to kind of get a sense of what's actually happening in the wild when, whether it's open source or otherwise, systems are protected. So really, really good stuff, Chris. As always, thank you. So we'll wrap up here in just the final few moments with giving you a sense of, okay, you know how the protections work. I introduced it. You saw how it behaves in a real world scenario through Chris. Well, what can you do about it? And specifically, if you are an Oracle customer, an OCI customer. So as mentioned, we have built out a library of open source images protected with Alchemist source capability. This is ultimately a component of our Alchemist repo product, but we've published to start with on the marketplace 4 different images that are protected with Alchemist source. So Nginx, Apache, Redis, Memcached. And these are Oracle Linux-based images, and they can be deployed like any other image that's on the marketplace. And they, if you're running, so ultimately, if you're running open source infrastructure in VM format, this is the way to go. And it's a turnkey deployment that's very, very simple to execute. If you've deployed any image from the marketplace, you know how to do it already. So this is just a screenshot of the actual listing, and there's a few others, obviously, and it's a paid listing. So it just taps into the credits that you've already got. So very seamless and simple deployment, and we'll be sure to share the slides with folks so they have access to the link directly, but just search for RunSafe on the marketplace, and you'll find our listings there very, very easily. Now, additionally, you may not be running images, Linux-based images, VMs, as part of your open source infrastructure. The move to containerized workloads is well underway, has been for some time. So part of the broader Alchemist repo offering includes a larger library of Docker images of open source tools, web servers, database servers. You see on the right a sampling of some of the things that are available in our registry, our container registry. So if you are deploying containerized workloads and, for example, using Oracle Container Engine for Kubernetes, perfect. Grab your container or Docker images from our container registry, deploy as you normally would, and you're good to go. The latest versions are available in the registry for these particular tools that you see on the right. But if something is not there, absolutely let us know. We want to continue to build it out. We want to use or make available what you're using on OCI. So don't be shy, work with us, and we'll make sure that we do our best to deploy the tools that you're actually using in your environment. So to summarize some of the typical challenges that we've kind of covered today, we know it's really difficult to patch all vulnerabilities, whether you know them or not, known and unknown. We know that the cloud is proliferating at warp speed, and you may not even have visibility into some of the software components that get deployed in your environment. You've got a heavy amount of overhead with existing security tools that inevitably will cause some sort of operational action to occur. If something is detected, you've got to remediate it. And that remediation effort takes time and energy and resources that you may not have available. And for developers that are deploying applications in the cloud or otherwise, they're going to be pulling in different open source components into their overall application. And if they're constantly having to remediate, then that's going to slow down the development process. So we seek to ultimately eliminate all of that, or at least reduce the friction and pain with a lot of these challenges. So your attack surface is reduced permanently by a significant percentage, 40% most of the time. And you're protected regardless of whether or not you actually have visibility into some of the things that are getting deployed in your environment. As long as they're pulling a hardened image down, you're good to go, whether you're scanning it or not. And the remediation is obviously built in. You don't have to take any action. If you're pulling down a hardened image from the marketplace or from our container registry, the protection's done. It's there. You don't have to do it. So you ultimately end up with zero operational burden. The code is intrinsically protecting itself. You don't have to gobble up resources for remediation for a huge class of attack methods. And you can deploy at speed, and developer velocity is preserved and if not enhanced. Now, where can you go to kick the tires on some of this stuff? We've stood up a portal. We call it the Alchemist portal. It's at alchemist.runsafesecurity.com. And a whole treasure trove of goodies up there, run through actual demonstrations similar to what you saw from Chris. So we've stood up an actual code environment where you can get on the command line and run through some of this stuff real time. And access to free trials and documentation. If you do actually want to deploy one of the images from Marketplace, just visit the portal, register. You've got a 30-day trial license that you can plug into that image that you're deploying on OCI, and off to the races. So that is the long and the short of it. Thanks everybody for joining. Really appreciate it. If there's any questions, we will take those now. I'm gonna just take a quick peek for any questions. A couple came in through some back channels here. So one question, I didn't address this. Is there a performance hit when running hardened images? Really, it's imperceptible. Typically, we see like a 1 to 3% performance hit during the randomization process at load time. But it's highly dependent upon the system resources. Where we see maybe at the higher end of that 1 to 3% is we can protect embedded systems and things that are low system resource type instances. But if you're on the cloud, as Phil was indicating, there are the system resources available are abundant, right? So it's going to be imperceptible in that use case. I think maybe one other question. So yeah, this is a good one. So if I'm building my IT infrastructure from source, can I harden those open source images myself? We actually do have a few customers that are doing that themselves, where they're rather than pulling in the compiled package, they're pulling in source and then compiling it themselves. And absolutely, if you prefer to apply the protections at build time, even with open source, we can help you with that. So you end up with the same results at the end of the day is hardened code, whether we do it for you or we help you implement it into your build process. So happy to enable both options. And I believe that is the last question. So I will wrap up. Just want to thank Chris, want to thank Phil for joining us. Really appreciate your content and collaboration. This has been great. So thank you.
You're welcome. Thanks for inviting us, Nick.
Absolutely.
Thank you very much.
Thank you, Chris. Yes, with that, I will sign off. Take care, everybody. Have a good rest of your week. All right. Well, thanks, guys. I'm going to stop the recording.